So section 14.6 in your textbook is about naming compounds. And we're going to use a very simple method for naming things. Turns out there are two different types of compounds. And because there are two different types of compounds, there are two different systems of naming those compounds. So it's really important to pay attention to what is in your compound, whether it's a metal or a non-metal, in order to name it. The first type of compound is called an ionic compound. All right, an ionic compound is a metal which is bonded to a non-metal. I'm sorry, that's really hard to read, but metals bonded to non-metals are ionic. Metals are on the right-hand side of the periodic table. This is the right-hand side.
That's the left-hand side, actually.
Did I just say it? Yeah, okay. Metals are on the left-hand side of the periodic table. I can't tell my left from my right, and that's becoming glaringly obvious. Metals are on the left-hand side of the periodic table, with the exception of hydrogen, which is a non-metal. So all of these things are metals. All the things down here, the intertransition metals, are metals. Non-metals are on the right-hand side of the periodic table. They are to the right of this stair-step line that you see drawn right here, and hydrogen. So if you have something on this side, the left side, bonded to something on the right side, it's a metal bonded to a non-metal and an ionic compound. When you have a metal bonded to a non-metal, the metal, which is the first element listed, it is written on the left, just like it's on the left side of the periodic table, keeps its elemental name. Okay, you don't change the name. The non-metal changes the ending of its name to IDE. Okay, so for instance, this is sodium and this is chlorine. So this is called sodium chloride. So all I did, instead of I-N-E at the end, I switched the end of chlorine to chloride. Li is lithium. Okay, that's the metal. I didn't change its name. This is oxygen. When it's in a compound, we call it oxide, O-X-I-D-E. So there it ends in "ide." Calcium is a group 2 metal, Ca. Okay, and fluoride. Instead of fluorine, it's fluoride. Hydrogen is treated as if it's a metal, even though it's not. It behaves like a metal. So we have hydrogen chloride. IDE. And then strontium, which is way down here in group 2, is a metal. So we have strontium phosphide. So instead of phosphorus, it ends in phosphide. So phosphorus becomes phosphide, chlorine becomes chloride, fluorine becomes fluoride, oxygen oxide, and chlorine chloride, where the first element, the metal, sodium, lithium, calcium, hydrogen, and strontium, remain the same. Molecular or covalent compounds, they can be called either thing, are nonmetals bonded to nonmetals. The first one, again, keeps its name, and the second one does end in "ide. And we count how many of each element are present using prefixes. So, prefixes that you've probably seen before in geometry or possibly biology. Mono means 1. The prefix di means 2. Or we can do 1 or 2 like that, symbols. Tri is 3. Tetra is 4. I guess since you're going to be looking for the symbols for the numbers, we'll use those. Penta is 5. Okay, so 1, 2, 3, 4, 5. Hexa is 6. Hepta is 7. Oops. Octa is 8, like octopus. Nona is 9. And the last one you're going to need is deca, which is 10. So you will be seeing written numbers rather than the names of the numbers in these formulas. The thing you do have to remember is we never use the prefix mono for the first element that's listed. It's only listed for element 2 and beyond. If we have more than one element or more than one atom of the first element, then we modify it using a die, but we don't use it here. So for instance, 1 carbon and 1 oxygen is going to give me carbon monoxide, where we've taken mono and taken off the extra O because then it would be monooxide. But we don't call it monocarbon monoxide. So anytime you have something with no prefix in front of it, and it's the first element, there's only one of them. So this you should all know. It's a product of cellular respiration. You breathe it out all the time. It's carbon dioxide. So carbon, because there's only one of them, has no modifier on it, but there are 2 oxygens, so it's dioxide. Di meaning 2. Okay, here again, we have something with only 1 nitrogen, so nitrogen keeps its name. We don't add a mono to the front of it. We have 2 oxygens, so it's nitrogen dioxide. Now we have 2 nitrogens. So nitrogen keeps its name, but it's dinitrogen. The prefix that means 4 is tetra. And you can write it as tetraoxide or tetroxide. So you can leave out that A if you want to. Here we have 4 phosphoruses. So tetraphosphorus. These can get long, but they're easy to do. Spelling does matter. So 4 phosphorus, that keeps its name. Sulfur as an anion ends up being sulfide, and there are 10 of them, so it would be deca sulfide. The last one, P2O5, 2 phosphoruses is diphosphorus. Di meaning 2, phosphorus the name of the element. The prefix for 5 is penta. So you'd say pentaoxide. You can leave out the A and just say pentaoxide if you want it. You do not have to put double vowels together. So we've taken this one, no prefix in front. We don't use the mono here, but we do use the mono there. Here we don't use the mono in front of the carbon, that's understood. So it's carbon dioxide. Again, here we have a single element first, we don't use mono, so it's just nitrogen dioxide. Here we have more than one element in the beginning, so we use a prefix, we have dinitrogen tetroxide. Here we have more than one element or more than one atom of phosphorus, so it's tetraphosphorus decasulfide, 2 prefixes. And here for the 2 phosphoruses, we have diphosphorus and then pentaoxide for 5 oxygens. And I think that is it.